So now we'll get to actually do some algebra problems with this. So if y varies inversely as x, so that tells you you're going to have the whole k over x relationship. And y is 4 when x is 7. So there you're just plugging it in. Then it tells you to find x when y equals 14. So we set this equation up, and then the easiest way to do this is just multiply. And you'll get k equals 28. And figuring out this k constant sets you up to write y equals 28 over x. So the whole idea is you've created this equation. Now with this equation, if you're given a coordinate, but you only have one of those two, you can find the other. So I'll write 14 in, since they give us that value for y, is equal to 28 over x. Now you could probably just look at this and realize that the answer would be 2, but I'll solve this algebraically. And I'll multiply by x so that I rewrite my equation as 14x is 28, and I'll divide both sides by 14, which then gives us that x value of 2 that we mentioned. The only thing it told us to do was to find x. So after we made the equation and applied it, we're done. If y varies inversely as x, and y equals 4 when x is negative 8, find y when x is negative 4. So just like before, we'll use this equation. With it set up, we'll plug in that value of 4 that they give us, the x value of negative 8, and we'll solve for k. Similarly, you might be able to say, well, that's probably 32, but I'm going to multiply both sides by negative 8 to solve it algebraically, and I'll get k is negative 32, and that's the first part of doing these problems. Back in the equation, now I can write y equals negative 32 over x, and I can plug in the value that they give us for x, and now we're finding y. So what is y if our right side of the equation is negative 32 over negative 4? So 1/4 of 32 is 8, and a negative divided by a negative is positive, so I box that and it's done. So now we're told to use inverse variation, so we're just going to be applying this to real-world problems. So with physical science, we have two people balanced on a seesaw. Their distances from the center of the seesaw are inversely proportional to their weights. So if I'm going to sketch this, here's person 1, person 2, and what they're saying is that their distances from the center of the seesaw are inversely proportional to their weights. So if a 118-pound person sits 1.8 meters from the center of the seesaw, how far should a 125-pound person sit? But what I want to point out is that, we can map this out and have 118 pounds for this person, who is at 1.8 meters away, and then we have the 125-pound person, who is maybe x or whatever mystery value distance away. So we'll just apply this inverse relationship of y equals k over x, and into this we'll plug in the two parts that we do know. Well, we know both of these. So I'll say that y, and if we keep this in the lingo that they use, like their distances from the center are inversely proportional to the weights, so this is y inversely proportional to x, then we could, really stick to the order and say 1.8 is going to be equal to k over 118. But it really doesn't matter. So to solve this part, we're going to figure out what k is. I'll multiply both sides by 118. For this, I'm going to take a calculator out. So, and I'll write what I got, which was 212.4. So now, when I go to plug this in, now if you drew that drawing, you're going to be tight on space over there. I'm going to write y equals 212.4 over x. And so now I'm going to plug in the value of the weight of the person. Now here it would matter. If I put the weight there, then I'm going to have to definitely treat x as the weight here. So I'll write y equals 212.4 over 125. And if I type this in, the result I got was 1.6992. So I'll keep with the rounding of the other value, and I'll say y is approximately 1.7, and then our unit for this is meters. If I go back and reread this problem, how far should somebody sit from the center of the seesaw? I mean, I guess we could write a sentence, but I think we've answered this pretty clearly. Earth science. If you want to, you can pause this, make it an OYO problem, and then come back and listen to what I say. As the temperature increases, the level of water in a river decreases. So it sounds to me like if I treated this the way we've been organizing these, we could treat temperature as y, and then the level of the water as x. When the temperature was 90 degrees Fahrenheit, so over here I'll write y equals k over x. When the temperature was 90 degrees Fahrenheit, the water level was 11 feet. If the temperature was 110 degrees, what was the level of water in the river? So we're going to use the same approach we've been doing. So I'm going to multiply both sides by 11 to figure out what the value of k is. And then 11 times 9 is 99. And then I'll put that 0 there. So this is the constant k. It is not measured in degrees and it is not measured in feet. It's just a constant. Over here I'll plug that in. So here's 990 for k over x. And then I have to make sure I keep the organization straight. So over here we used 90, which means that this 110 for temperature is y. And as I look at this, I'm thinking, well, I probably can guess what this is. But I'll still multiply by x. And then I get 110x is 990. Divide both sides by 110, leaving me with x is equal to 9. And the units on this are feet. Now whenever you're doing a word problem like this, we want to check to see if this is reasonable. So as the temperature goes up, the level of the water decreases. I guess that's kind of sensible. Warmer temperatures evaporate water. So here the temperature was 90. So I had 11 feet of water. Now if the temperature is significantly higher, I can expect the water level would go lower. Now, maybe dramatically, maybe not dramatically. It depends on how large these values get. But I checked that, and that seems pretty reasonable. If I would have got a larger value than 11, I would know that that was off. So this will conclude the notes for 11.1, and this will be your assignment that goes with it.